Okay, here I am at practice test number 2. I'll go through this as quickly as I can, but also try to explain things clearly, so you can just pause and re-listen if you need. Problem number 1, this is log of 1000. Of course, when there's no number, we know that if it's log, that's log base 10. It's going to be equal to something. We can call that x, and then cancel the log. If we bring this over using our arrow technique, that is the base we build that on. So 10 to the x equals 1000. Well, 10 to the third, because there are 3 zeros, equals 1000. So this just equals 3. Okay. With this one now, it's log base 5 of 5 equals something. Call it x. Do the same thing. We're just doing the same thing over and over again. 5 to the 1 power equals 5, so this just equals 1. Alright, there's that answer. Same thing here. Bring the 4 over as the base number. That's what x will be equal to now. So 4 times itself 3 times is 16 times 4 is 64. Okay? Again, we've got an implied base of e. When we see ln, that's the natural logarithmic base. E is just that number, 2.71. You should read about what that is so you kind of know what it is. That's going to be equal to something. Again, we bring that over, cross that out. E raised to the x power gives us 1. Well, the only thing that you can raise to give you 1 will be 0. So this is equal to 0. Okay? This one now is a root. It's not a log problem, but we want you to know about exponents and roots. So we're looking for 3 numbers that multiply to make 125, and this one happens to be one of your special numbers, so that's going to be 5. That can come out. If you want to factor it, that's a good way to go. 5 and 25, and then 5 and 5. That gives you that hockey stick where we're looking for our multiple numbers that are the same. 3 numbers, because it's a third root, so I can bring out a 5. Actually, I'll bring it out this way. 5. There are 21 x's there. I'm looking for batches of 3. I can take out 7 batches of 3, so that's x to the 7. Again, I'm looking for batches of 3. I can take out 2 of them. That makes 6. When I take out 2, that's there, but what's left behind is one lonely y. So write third root of y, and that is your answer like that. Okay, I got interrupted with a cell phone call, but I'm back. Here we are at problem 6. We've got this fraction. That is the root number. You really need to know that that is the number that makes it go down. So we're looking for a number that multiplies by itself 3 times to give you 125. Well, that's deja vu all over again. We've got 5. So that's going to be 5. And then a number that multiplies by itself 3 times to give you 343. Look on your chart of numbers, which you'll be able to use, and that's 7. And then this is going to be to the minus 2 power. Well, that minus flips the fraction. So that's going to be 7 over 5 squared. So that will just be 49 over 25. Okay? Now we're at this expanded log, which we're going to write as 1. We have our 3 rules of logarithms. You should know what those are by now. If I'm adding a and b in the same base, they have to be the same base, this is going to be 3 times then the log of a times b, then minus 2 times the log, oh, that's log base 5, log base 5. I won't take off points if you forget that once or twice, but make sure in the final answer you have it. Then this is letter C, and that's times a. Alright, so we got a again. Well, now I've got 2 logs that are being subtracted, and I've got this number out front. Well, that goes inside as an exponent, and that goes inside as an exponent, and then when I subtract them I can just write them one over the other. So this will be then a single log base 5, and it's going to be a to the third, b to the third, because I can bring the exponent into each of those, over I'll put a squared times c squared, and you can see the a's down here cancel with the 3 right there, and so you wind up with ab to the third over c squared. Okay, so I don't know if you need to write it again. I'll write it up here. Log base 5 of ab to the third over c squared. That's the final best answer. All right. This is graph and find the inverse of this function here, and then when we find the inverse, state the domain and range. All right. There was a typo, unfortunately, in your test. I said x is greater than or equal to 0. If that made total sense to you, that might have thrown you off, but perhaps it didn't. I'm sure you could still go through the math of finding the inverse. But if we have, I'll put my graph over here, I guess. Here's our axes. And I'm going to graph this. A simple way to do it is to make a little chart with x and then f of x. You notice that if I'm restricted to numbers that are equal to 5 or greater, I might as well start at 5. I plug in 5. 5 minus 5 is 0. 0 divided by 2 is still 0, and then squared is 0. So it's going to start from there, and if I go up by 2's maybe to 7. 7 minus 5 is 2, over 2 is 1, 1 squared is 1, and I'll jump to maybe like 11. 6 divided by 2 is 3, 3 squared is 9, and then maybe one more at 13. That's going to be what, 8, and that's 4, so it's 16. Alright, so if I go 5, 10, 15, 20, like that, and then do 5, 10, 15, 20, like that, that's pretty good. And if I go 0 and 5 is right there, or 5 comma 0. 7, 1 is just a little bit like this. 11, 9 is approximately like that. And then 13, 16 is approximately like that. So you can see this, this is going to be, it's a parabola, so actually I've cheated a little bit. I thought it was going the other way. It's going to go up, but about like that. All right? Then finding the inverse, we swap this for a y, and it's going to be equal to that squared, so then it's x minus 5 over 2. Then I swap the x and the y. This is where we find the inverse. X then is equal to y minus 5 over 2, and that's squared. And now we just undo the layers to get at the y. Alright? So the outermost layer is the square, and I undo that by square rooting. Alright? And then that's gone. And then I undo the divided by 2 by multiplying by 2. So then I get 2 radical x equals y minus 5, and then I just have to add 5 to both sides. So 2 radical x plus 5 equals y. Alright? So then this just will become, in the proper form, f to the minus 1 of x. That's the inverse of x, we say, and that's equal to 2 radical x plus 5. So it'd be great if you wrote the answer like that. Then we know that inverses are always the reflection over this 45-degree line. Alright? So I can just sketch that reflection. If this is at 5, 0, it'll be 0, 5. And I can try to show that by plugging in 0, and yeah, that is 5. And then it will just go like this, and I'll draw a long dash like that. And if I kept this going, this would go like this, and this would go like that, and there's my inverse. Alright? The domain for this, the domain is going to be all x values greater than 0, so x is greater than or equal to 0, and then the range, my values coming out, are going to be only greater than 5. So the range is f minus 1 of x must be greater than or equal to 5. Okay? That's that right there, the whole thing.